Hello friends, welcome for this lecture. Today we are going to discuss the topic on slip of induction motor. Okay. So before going to discuss about slip of the induction motor, we'll speak is NR is equal to NS. Okay. So meaning of this one is NR is the motor speed. Okay, or you can say it is the rotor speed in RPM, and NS is the synchronous speed of the motor. Okay, or you can say it is the speed of the RMF, rotating magnetic field. Okay, is these two are equal. Okay, as we have seen the operation of this induction motor. Okay, main cause of a rotor to rotate. Okay, so main cause of that is, let's consider this is the stator and this is the rotor. Okay, as the supply is given to this stator, what happens there, magnetic field, that is rotating magnetic field, will be produced, and due to this uh, rotor conductor linking with the flux or rotating magnetic field, there will be an induced EMF because of this reason. Okay, induced EMF in the rotor. Once the rotor get EMF, what happens there? So rotor EMF starts producing, means it allows to current to flow through it, so that is called as rotor current. Okay, once rotor current starts flowing in the rotor, what happens is rotor conductor, so as we have seen, any conductor carries a current. Okay, carries a current that produces a flux. Okay, again what happens here is this rotor is start producing its own flux, is called as rotor flux. Okay, now this rotor flux and RMF. Okay, so due to this, what happens there, relative motion between, okay, relative motion between the rotor and the stator is going to happen, and then what happens is this entire rotor conductors experiences a force. Okay, then rotor experiences a torque. Okay, and then the rotor starts rotating. This is the cause of it. What is RMF has to move, and means RMF is here, and then a conductor linking with a conductor. Okay, or flux is going to produce EMF in that. Okay, what happens if NR is equal to NS? What happens is, if NS is the stator speed, that is RMF speed is moving in this direction. Okay, let's take, right, then the rotor will start rotating in the same direction. Okay, with a lesser speed. But what happens if these two are same, NS and NR, if these two are same, what happens here? So this is also rotating in the same direction, this is also rotating in the same direction, as well as the same speed, then there is no flux linking with the conductor. Okay, remember, there is no flux linking with the conductor. When there is no cut of a flux, okay, when there is no flux linkage, then there is no EMF produced in it. Okay, when there is no EMF produced, then there is no current flowing through the rotor. When there is no current flowing through the rotor, there is no flux produced by the rotor. And then there is no, when there is no flux, or and then there is no, what happens there, there will not be a torque. So what happens, so this NS and NR will be get vanishes when these two are equal. So EMF will not be there, current will not be there, right, and then there will not be relative speed, okay, between the NR and NS. The rotor again stands stills. Okay, means it will not rotate. This is why NS, this is why NR or rotor speed will not be equal to NS. Okay, therefore what happens is, just remember this sentence, in the induction motor, the induction motor never rotates at a synchronous speed. Meaning of this one is NR will not be equal to NS. It meaning of this one is always your rotor speed will be lesser than your synchronous speed. Okay, so it can be said that a rotor slips behind the rotating magnetic field produced by the stator. Okay, so what is this slip speed? What we have said is a relative speed. Okay, this is NS minus NR. Okay, so remember, NR will be lesser than NS. Okay, so you can get a difference between these two. Ns minus nr is called as the slip speed of the motor in rpm. Okay, and this slip speed decides the magnitude of induced emf and the rotor current, which in turn decides the torque produced in the rotor. Okay, and now we'll speak about slip of the induction motor. What is this slip? Is nothing but, as we know, this is ns minus nr is the slip speed. Okay, is the relative speed. Okay, so slip is defined as the ratio of slip speed to the synchronous speed. Okay, slip is defined as the ratio of slip speed, as we know slip speed is ns minus nr, to the synchronous speed. Okay, and then in percentage, if you would like to express, then it has to be known, it will be like, s percentage will be equal to ns minus nr divided by ns into 100. Okay, then let's take from this equation. It is a very important equation for us to find out the slip, right, as well as to find out the nr. Okay, as we know, s is equal to ns minus nr divided by ns. Just simplify this. Okay, ns into s is equal to ns minus nr. So what happens is, nr equal to, you take nr equal to what, ns minus this ns into is. Okay, nr equal to ns, if you take from these two factors as a common, then there will be 1 minus s. So this is equation for a rotor speed or motor speed, nr equal to ns of 1 minus s. Okay, then remember, at a starting, motor will not be rotating, means it is at a rest, hence speed will be nr equal to 0. If you substitute nr equal to speed, nr equal to 0, so what happens there, meaning of this one is s is equal to 1. Okay, when s is equal to 1 comes, 1 minus 1 is nothing but a 0. Here nr equal to 0. So s is equal to 1 is the maximum value of slip. Okay, slip maximum value itself is 1. Okay, so then what happens here, this is the maximum value, that is s is equal to 1. Slip will not be greater than 1, this you remember. Suppose if s is equal to 0, as we know this equation, nr is equal to ns of 1 minus s. So if s is equal to 0, if you substitute s equal to 0, nr will be equal to ns, which is not possible for this induction motor. Okay, so what happens here is, slip of induction motor cannot be 0 under any circumstances, right? So practically what, s should be maximum value is 1 and it should not be equal to 0. Meaning of this one is, practically motor operates in the slip range of 0.01 to 0.05, that is 1% to 5%. Okay, around this our induction motor is going to work based on this slip. This is also called, you can say it as, the slip corresponding to the full load speed of the motor is called as a full load slip. Okay, this is about slip speed. Okay, thank you.